Okay, so I forgot in that last lesson to prove the first consequence for you guys. So let me correct that now. So we had stated three rules that were three consequences that followed pretty directly from the Kolmogorov axioms. This was the first of them. The second one is going to be your quiz for this lesson, and the third one is going to be a workshop. So this example will get you going to work on the other consequences. Okay, so we've got this claim that the probability of the complement is 1 minus the probability of the event, and what are the steps to show that that's true? Okay, so the first step, I'm just going to note that E intersect E complement is the empty set by definition of complement. That's what complement means. So E and E complement are mutually exclusive. Great. So we know about mutually exclusive sets. We have the probability union E complement equals the sum of the probabilities, the probability of E plus the probability of E complement by that third Kolmogorov axiom. That's exactly what it said. It said if you have mutually exclusive events, the probability of the union is the sum of the probabilities. So we're just applying it in a very straightforward way there. But E union E complement equals S. And again, this is kind of the other side of the definition of a complement. If we start with E, how do I get to S? Oh, you add in all the things that are in not E, okay? And we're bringing in another axiom here. The probability of S is 1. That's what the second Kolmogorov axiom tells us, okay? So we've got it all here. Now we just need to put it all together, okay? So we started with 1. That's the probability of S, which is the probability of E union E complement. What I'm doing here is I'm just like working backwards up my steps here. So 1 is the probability of S. S is this. Where'd I go? Let me go back to the document I was working on. Probably has a time like untitled. No, that's not it. Here it is. Okay, that was a strange little event there. What was I doing? I was showing this thing. We'd gone through all of these steps, each justified by a definition from set theory. So steps 1 and 3 are from set theory. Steps 2 and 4 are applying axioms. What I'm doing here in step 5 is I'm just putting them all together. And as I said, I was kind of like working my way up. So the probability of the sample space is 1, but the sample space is E union E complement. The probability of E union E complement is the sum of the probabilities. Okay. So I'm putting that all together. I'm writing all my justifications, so I might as well write what I'm doing here. I guess I'll just say I'm consolidating. And now what we have here is just, maybe it's not obvious, but I really want to point it out. This is just an equation or a set of equalities involving numbers. All those probabilities are numbers. So now I'm just in the world where everything I know about the algebra of real numbers is what I need to simplify here. Okay, so getting rid of the kind of the intermediate steps, I've got my 1 here and my sum of the probabilities there. So 1 equals the probability of E plus the probability of E complement, and we can just rearrange that as the probability of, I write it backwards, probability of E complement is 1 minus probability of E. And that's what we were trying to show. Yeah, so it's kind of fun to do these derivations. Again, let me just sort of emphasize that the justification for each step is typically going to fall into 3 different categories. Category 1 is stuff from set theory. Okay, so applying like the definition of a complement or De Morgan's laws or the commutative property of sets, those kinds of things. We're also going to be using the Kolmogorov axioms, right? And so we applied them at 2 points. And then at some point, we get down to where everything is turned into probabilities. It's just all real numbers. And then it's pretty much just basic algebra because we're working with numbers and we know how to manipulate expressions involving numbers. Okay, so that is an example of this kind of derivation. And as I said, you'll get a chance to do a couple of them as well. Have fun.